Hello and welcome. The data has just come in, and it's not quite what many anticipated. Right now, as you're watching this, an object from another star system is racing through our cosmic neighborhood at around 200,000 kilometers per hour. We've directed our most advanced instruments toward it. We've listened with receivers capable of picking up a faint cell phone signal from millions of kilometers away. And what we've discovered, or more precisely, what we haven't, has divided the scientific community. Tonight we're exploring the latest analysis of 3I Atlas. Because the observations are finalized, the numbers are out, and I need to explain why this seemingly straightforward conclusion is far from simple. Let's examine the data more closely. This isn't merely another rock. 3I Atlas is only the third confirmed interstellar object in history to enter our solar system from beyond. Reflect on that. For centuries, we've gazed at the night sky, assuming every moving body belonged to our sun's family: comets, asteroids, planets orbiting our star. Then came Oumuamua, then Borisov, and now 3I Atlas. Three visitors in under a decade. It prompts the question, is interstellar traffic on the rise, or are our detection systems finally catching up? The object moves extraordinarily fast. We're tracking velocities on the order of 200,000 km per hour relative to the Sun. To give perspective, that's quick enough to cover the Earth-Moon distance in under 2 hours. At such speed, the Sun's gravity barely slows it. It isn't captured, it isn't lingering, it's a swift flyby, and that velocity is precisely why observations were urgent. The window wasn't years or months, but weeks, and that window is rapidly closing now. Before we delve into the new findings, particularly the debated radio results just released, if you want to stay ahead on this evolving story as we sift through fresh observatory streams, please hit subscribe. We'll track 3I Atlas until it slips beyond our strongest sensors, and you won't want to miss the developments ahead. Now, returning to the trajectory. Plotting 3I Atlas's path shows it plunging deep into the inner solar system, swinging close to the Sun, then shooting outward. It's a hyperbolic orbit, the clear hallmark of interstellar origin. Unlike Oumuamua, which tumbled erratically and accelerated unexpectedly, 3I Atlas seemed, optically at least, more conventional, or so initial views suggested. Early optical and infrared data suggested a typical cometary nucleus. Size estimates vary from hundreds of meters to possibly several kilometers, a broad uncertainty due to the challenge of sizing a fast-receding target. It's akin to gauging a departing bullet's dimensions. We observe a coma and a tail, classic indicators of ice sublimating under solar heat. But here's where the story pivots. While optical scopes counted photons, another kind of receiver tuned in, a far more expansive one. The community recognized that if this weren't just frozen rock and ice, if even a remote chance existed, it was artificial, a derelict craft or something unknown. We had to listen actively, especially at closest approach. The reasoning holds. A traveler in a foreign system might emit signals, leak radiation, or use radar for scanning. Optical sees reflected light, radio detects activity and energy. So the call went out. Breakthrough. Listen, history's most extensive SETI effort secured time on one of Earth's premier instruments. They weren't merely observing, they were probing intensely. The key date, December 18, 2025. Geometry was ideal. Distance minimized. If 3I Atlas had anything to transmit, this was the window. Tension-filled control rooms. We weren't hunting a comet. We sought a techno-signature, proof we're not alone. But as we review those scan results, grasp the stakes. A detection would rewrite history instantly. A null result? That's where true science ignites, because silence in radio astronomy is itself meaningful, defining boundaries of the possible. The object traversed the inner system under scrutiny from our cutting-edge tech. We aimed everything at the radio domain, and the outcome, or lack thereof, has sparked intense debate on assumptions, methods, and our cosmic search strategies. We shift now from optical tracking to radio. We head, figuratively, to West Virginia beneath a giant dish to unpack December 18th. Because the returned data isn't as clear-cut as headlines suggest. The top line, no signal. Yet the details murmur otherwise, hinting at our perceptual limits. Let's visit Greenbank. Imagine standing in West Virginia's quiet zone, shielded from modern interference, where the Robert C. Greenbank telescope rises. A 100-meter marvel, larger than a football field, the world's biggest fully steerable single-dish radio telescope. On December 18, 2025, this ear locked onto 3i Atlas, not a casual scan, a deliberate high-sensitivity interrogation of the interstellar guest. Breakthrough Listen prioritized it due to proximity, timing aligned with near-Earth approach. If a whisper existed, this captured it. Methodology is key. You don't just tune broadly, you select frequencies. The team swept 1 to 12 GHz, the waterhole and adjacent quiet zones where galactic noise dips low and atmosphere allows passage. Classic SETI territory spanning Wi-Fi, satellites, deep space radar. Billions of channels checked simultaneously for anomalies against cosmic background. Crucially, they hunted narrowband signals. Nature tends broadband, explosions, accretion, jets spread energy messily. Technology narrows it. Precise, efficient, informational. Narrowband marks engineering. On December 18th, Greenbank tracked 3i Atlas across the sky, dish compensating for Earth's rotation and the object's speed. Receivers cooled near absolute zero to cut noise. Back-end supercomputers processed petabytes, running Fourier transforms live, seeking spikes, sharp lines, tones, patterns. Sensitivity was extraordinary. Persistent signals detectable down to about 100 milliwatts. Consider that, equivalent to a smartphone linking to a tower. A cell phone in space, millions of kilometers distant, transmitting omnidirectionally in that band? Greenbank would detect it. That's the precision. They filtered satellite interference, a major radio astronomy hurdle, distinguishing terrestrial from extraterrestrial. They sought Doppler drifts from relative motion, a signature tying signals to the target, not local sources. All done, then published in preprint. Result: flat. No candidates, no narrowband emissions, no beacons, no telemetry. The paper frames it as a firm negative, setting upper limits. No continuous radio beacon in LSCX bands above 100 milliwatt on December 18th. But science thrives on nuance. A negative isn't proof of absence, it's non-detection under defined conditions. We proved capability, we heard silence. What does silence signify? Natural object or wrong assumptions? We examine what wasn't covered, the data's shadows, because even Greenbank's prowess has bounds, and 3i Atlas evades masterfully. As we dissect the non-detection, recall the 100 millibarn benchmark. Impressive, yet assumption-laden. In SETI, assumptions are perilous. The Breakthrough Listen verdict: no techno-signatures. This tempers earlier hopes. Interstellar visitors spark imaginations. Rendezvous with Rama, awakening probes. We anticipate contact. December 18th. Data: cold, empty. Negative results matter. They prune possibilities. We know 3i Atlas isn't broadcasting loudly. No emergency transponder in standard bands. If technological, it doesn't mimic our noisy probes. Voyager, New Horizons phone home constantly via directed antennas. Yet silence isn't total. Before labeling it rock, consider: is it absolute? This midpoint, your input, does a negative radio sweep prove natural origin, or could tech stay quiet? Comment below. I read them. Strong ideas may feature in follow-ups. The paper notes detection capability assumes continuous signals during the window. Radio searches are temporal snapshots, like peeking at a house for minutes. If no lights, music, movement, is it vacant, or occupants quiet elsewhere? Observation was high-res but brief. 3i Atlas sped by. Telescope tracked. If transmissions burst, millisecond pings hourly, odds of catching one are low. Narrowband focus is SETI standard, Nature avoids it, but advanced tech might use spread spectrum, mimicking noise without the decode key. Our military does this for stealth. Frequency range 1 to 12 GHz is broad but partial, not optical lasers, though other scopes watched, not for ultra-short pulses, not lower higher bands. The null is precise, no continuous narrowband radio 1 to 12 GHz on December 18th, not no aliens, but no such signal in this window band. Vital distinction. Absence of evidence isn't evidence of absence. Methodology limits prevent universal no. We're left puzzling. It resembles a comet, acts cometary, stays silent, cometary. Occam's razor favors natural, yet interstellar origin keeps the crack open. If artificial, why quiet? Damaged, passive, ignoring us? Nulls are clean, interpretations messy, hypotheticals exist, physically viable, where artificiality evades Greenbank. We explore those shadows, testing methods. In interstellar hide-and-seek, seekers need luck always. Hiders once. Silence scenarios. Directed beam, omnidirectional wasteful, tight beam to home relay misses Earth, odds astronomical. We'd miss a transmitter pointed away, like side viewing a flashlight without scatter. Radio silence strategy. Deliberate quiet in scrutinized zone. Paranoid? Perhaps. But submarines go silent in unknown waters. If surveillance probe, it gathers, stores, bursts later in deep space. Silence expected. Exotic channels. Radio primitive. Neutrinos, gravity waves, entanglement beyond our monitoring. We're bottle messages. They might use galactic networks. No evidence clearly stated, but illustrates. Radio null bounds our search, not reality. Public asks, no signal, rock. Likely, not certain. Space junk, dead relic, spent stage, Dyson fragment, transmits nothing, tumbles silently. Radio useless, need shape, rotation, composition. Radio was necessary long shot. Real narrative, motion, sunlight reflection, solar-wind interaction. NASA measured physicals. Less fiction, more science. Picture incomplete. Closest Mar 1.8 AU. Asteroid belt range, no close skim. Optical resolution limited. Point source, brightness inferred size, hundreds meters to kilometer, vast range. Tail suggests ice dust, spectra still refining composition. Silent, fast, cometary-looking stellar origin object. Radio silence one tile in assembling mosaic. As 3i Atlas recedes into interstellar dark, trajectory and science paths converge. Excitement of signals fades. Optical analysis grinds on. Galaxy not empty, full of wanderers. Oumuamua strange, Borisov familiar, 3i Atlas elusive. Each teaches, solar system no walled garden, part galactic flow, material in, out. Investigation winds down, search expands. Breakthrough, listen persists. Vera Rubin Observatory soon online, potentially hundreds ISOs ahead, from anecdotes to statistics. Next catch earlier, time for intercept, sample, probe. Until then, 3i Atlas, a silent enigma, vast quiet universe reminder, mysteries await right tools, frequencies. As 3i Atlas fades beyond telescopes, synthesize. Radio yields, dated, quantified null, no 112 GHz continuous narrowband above cell phone power, December 18th. Hard constraint for theories. Highlights instrument limits, vast universe, narrow windows. Conservative view prevails. NASA, no Earth threat, min 11.8. AU, 200,000 km/h relative sun. Natural ejection, dying star gravity kick, ancient chaos. Drifted eons, entered, heated, side gas, departs. Ordinary comet appearance, behavior, emissions. Geological messenger, primordial samples, no greeting. Yet precise silence in fleeting window doesn't slam door. Leaves sliver of what if, fueling curiosity. If this deep dive into unknown science engaged you, it signals demand for intelligent, data-driven content. We'll watch skies. 3i Atlas shows anything might pass through. Story continues. Silence a finding. combined with tracking, conservative yet intriguing picture emerges. Stay tuned.